I don't want to stand up yet. Because I want to talk to you as a peer, not as a professor. And I want to remind you that the bulk of the education that takes place at the university is of undergraduates. And that 90% of our undergraduates have no class past their senior year in this department. And when you have that type of responsibility, that means you're trying to guess what's going to happen for 40 or 50 years in the future. Each of you can think of what you were taught and how it applied. And some of you I talked to you over lunch were talking about a career in the petrochemical industry. And of course, what we gave you fit that perfectly. But I suspect that in the future, in another 40 years, that won't fit as well. And so when we teach undergraduates these classes, we have to think about, we have to guess what's going to happen 40 years in the future. I don't mean to pretend that the education of our undergraduates will stop. I don't mean to pretend that it's not their responsibility to do lifelong learning. That's not what I'm saying at all. I'm saying it's our responsibility to put them in a position where they can most effectively practice lifelong learning. And that's what I'm going to talk about. I'm going to talk about how you guess the course content that will be useful for the next 50 years. Okay? That's a very real kind of a challenge, and it takes us from these students. You can start to think of these things. What is the scope of the education? How are you going to teach it? What is the future content going to be? And I can tell you roughly what the answers are just right away. What's the scope? The scope is going to depend on what the discipline is and how you define a discipline, and I'll tell you what that is. And then I'm going to tell you about the content. And the content, the way in which you teach is going to stay the lecture. People say, well, there's an electronics revolution, that ought to make the lecture change. It'll make the lecture change. But after all, the lecture survived the previous electronic revolution, the previous information revolution, which was called the printing press. and the lecture didn't disappear with the advent of the printing press, and I think will continue. And then third, I want to talk a little bit about these speculations for what the future content will be. So I like bicycling, and I'm not very good at it. And so what I do is I prepare, before I go bicycling, questions to ask the people I'm riding with that have preferably very long answers involving heavy words, because that makes them a little more out of breath, and I have a chance to keep up, okay? And so in particular, I talked with one expert on German folklore. I talked with him about what makes a country. And there's a very large, believe it or not, a very large literature about what makes countries, especially Germany. How did roughly 70 different governmental organizations manage to merge? And what the folklorists believe is that there are two keys to this merger, this synthesis, this combination. And the two keys are poetry and grammar. You have to have poetry and grammar before you get started. And the poetry, in the case of the Germans, is supplied by Goethe. And the grammar is supplied by Jacob Grimm. And the fascinating thing about Jacob Grimm, yes, this is the Grimm in the Grimm fairy tales. This is the elder of the two brothers. And the fascinating thing about Grimm is that he himself did not speak German. He spoke Swabian. And so when he spoke the grammar, when he developed his grammar, he was thinking of doing this in a foreign language. Okay, now the challenge is, what can you say about different disciplines? For example, about chemical engineering, what can you say about how you can make a discipline? What are the poetry and the grammar that you need to develop a discipline? Now, I must apologize in advance that I'm going to make allusions to material science, but I found that I didn't know enough about it to really effectively talk about material science. So I'll give you some examples when I can, but most of this is going to be oriented towards the much smaller and much more recent discipline of chemical engineering. So now, what are you going to do here? Poetry is clearly the science, and grammar is the engineering. So that's the structure. And if you look at the people who supply this for chemical engineering, the person who supplies the poetry is the periodic table Mendeleev. I mean, that's what gives you this wonderful structure. That's what is the difference between the chemical sciences and physics. That in chemistry, you're stuck with basically 90-odd Legos, and you got to build everything out of those Legos. Whereas in physics, you can have any wavelength you like. I mean, it's kind of cheap. So, and the grammar, and this may be less knowledgeable, comes from the basic idea of unit operations. And unit operations, led by, in this case, the man is Arthur D. Little, who ran a committee in 1917 that decided on the basic structure of the discipline. It basically is that distillation of hydrocarbons is the same as distillation of anything else. Now, that to me is so axiomatic that I thought everybody believed it. And I once gave a talk on blood oxygenators and was told by the doctors in the audience that I could not take correlations for oxygen and water and use them for blood. Okay, they were serious. Okay, that they did not understand that the purpose of science and engineering is to generalize in an effective way. And if you do that, you can understand so this is basically the structure of chemical engineering. So that's easy enough. Now, if you think about material science, it's a little harder. This is a detail. This is Vulcan right here, you see. And right away, you're what, 12,000 BC? I mean, you're dealing with a different level of understanding of this at all. And then over here, you can see these are clearly Vulcan's graduate students. They're sweating and sort of in the middle of everything. And then you've got this one character over here. You'll all know who this is. This is a guy, somewhat still informally dressed, but he has kind of an aura around him. So this is Frank Bates. and what he's saying, it's clear what he's saying. He's saying to Vulcan, pounding on his, he's saying, haven't you ever thought of polymers? So if you think about the scope of the education, you're thinking grammar and poetry. Those are the things you start with. And now you think how the content is taught. And when you think about content, how it's taught, there are two basic models. The first of the models is this man. Just had his 500th birthday. This is John Calvin. My wife said, with a group of chemical engineers, I should be very careful to point out that this is not Kelvin. Okay, this is Calvin. And the thing about Calvin's lectures is that he spoke the truth, and any queries of this were out of line. The best evidence of this is the case of Michael Cervitas, who is a Spanish graduate student who once asked Calvin if he was sure he was right. And Calvin had it burned at the stake. Now, many of you may have felt that your professors would do that for you if you asked the wrong time. So that's basically, and that form of traditional lecture, this very Germanic form of lecture, where the knowledge flows from the professor to the student, that's a model that at the moment is in disrepute. What you want instead is the model suggested by Socrates. Now, Socrates, you already know from the idea of Socratic dialogue, don't you? A dialogue, what's the characteristic of a dialogue? It has to have two people. So in a Socratic dialogue, you're basically talking about two people interchanging it. The truth is not going one direction. The truth is going another direction, in many directions. Here's an example of detail of a painting by Raphael in the Vatican called The School of Athens. It's had some modifications. Socrates there did not originally have a hard hat. And Diogenes was without a laptop. But also you notice that I especially like that the Latin engravings in the back says things like urea and nitrate. Okay. Now, the point about this is, look how knowledge is being transferred. Sure, Socrates is talking to Plato, but he's listening to the answers. And other people are working by themselves or they're talking with others, or they're arguing. There are adults and students sort of in conversations. Information, everyone is learning. It's this marvelous form of controlled chaos that is so attractive of an active lecture. And that's the kind of lecture that people want to go with. They want to go to lectures so the knowledge is going every which way at once. Everyone is learning. And so that means, how's the content taught? Calvin versus Socrates, vote for Socrates. Okay? So first, what did I tell you? Grammar and poetry. Remember those two things. That's how you define the discipline. If the discipline changes, watch how the grammar and poetry change. If you're talking about how you make the presentation, make sure you can't have total chaos. I mean, every once in a while you have to say, oh, come on, you guys, shut up. And have everybody be quiet for 30 seconds. It's amazing how a class cannot sit still for 30 seconds after. Okay, now, you want to do all sorts of things. You want to say, graph out the results for the person next to you. Okay? You want to say, which quantities in this equation can actually be physically measured? And if you put on this sort of constant dialogue of this sort of challenge, the class is more effective. All right, now, what will the future content be? I show you this for two reasons. One is, this is the classic book by Walker Lewis and the Cadams that is normally credited with defining the substance of chemical engineering. This is University of Minnesota's copy, and of course it says up at the top that it's property of MIT. I had no idea why this is. But the funny part is, if you look in this book, you find that the chapters correspond one-on-one to the courses in our curriculum. It's a 1923 text, and there's nothing new. Now, of course, there's lots new. If you look at the chapter on kinetics, for example, it contains all kinds of studies of cold. The whole chapter's cold. There's nothing on catalysis, there's nothing on fluid beds, there's nothing on any sort of the things that we would normally teach in classes like that. But that's basically the structure of that curriculum. The class, the designation of classes, the way in which the discipline is broken up, has not changed. There's one exception. We no longer teach crushing and grinding. Okay? Here, now Professor Keller just self-identified himself as really old. I think that it's interesting that the two speakers that get to talk about the future, he and I, are the oldest two. Okay. So let's talk about what could be the future. And one of the futures that's quite clear is going to be a demotion of hydrocarbons as a standard fuel. And this was alluded to before. This is a pilot plant that I and my collaborators run in western Minnesota. You probably didn't know this, but this pilot plant is on the Continental Divide. Now you're thinking, what do you mean? You're just trying to sell me lots of stuff. But I know where the Continental Divide is. It's in the Rocky Mountains. No, this is on the Continental Divide. It's not the Continental Divide you think of. This is the Continental Divide between the Atlantic and the Arctic. And the reason that this Continental Divide is such a good place for wind power is because the tallest thing between our pilot plant and the North Pole is the Radisson and Duluth. The wind comes rolling down off the Arctic, and there's nothing in its way. And so there's enough wind energy in Minnesota. There's enough wind energy in Minnesota to power the country. Now, if you have that sort of wind power, and you want to make it into a portable form, and in that portable form, you want to build a new chemical business, that looks feasible. Now, could we do this with our current curriculum? No. One of the things we're going to need is a lot more information about, for example, batteries, about alternative ways to store the energy. There's nothing wrong with wind and solar except when the sun goes down and the wind stops. Okay? So you're going to have all kinds of load leveling difficulties that are going to be implicit. But if you look at the classes, my guess is the classes that we have will be bent by our graduates into forms that are useful for this business. Okay? I don't feel bad about that. Let me give you a second example where we don't come off so well. This is a minority plot. Do any of you recognize it? This was by a French civil engineer who in his retirement actually started looking at different ways of showing data. And this shows Napoleon's march on Moscow. And it's worthwhile to see how much it actually shows. If you look over here, this is his army when they leave. When they leave. And the width of the band is the size of his army. Okay, so he marches on Moscow, he gets over to Moscow, and the black line is his army coming back, the retreat from Moscow. And down here at the bottom is the temperature in degrees Celsius. So they hit minus 38 degrees Celsius, which is rough for winter camping, even if you're from Minnesota. Okay. Now, not surprisingly, Napoleon began with 472,000 men. 472,000 men. And he finished with 4,900. You're saying it's a disaster, isn't it? Now listen to me. By the standards of the drug industry, that campaign is a success. It is. You hit 1 in 1,000. You hit 1 in 1,000 in the drug business, you win. Okay? Well, that clearly is nonsense, right? You can't build it. Look, no one's complaining healthcare cost is too low. It's not high because it's expensive to make the drugs. It's high because it's expensive to make all those duds. Okay? So, can our courses handle addressing this type of huge problem? Now, they can handle the manufacture. If you know which drug you're going to make, they can handle the manufacture of that. And they can handle its purification. We teach classes in crystallization and so forth. We can handle that part. The part we can't handle is the drug discovery. What are you going to need for that? You're going to need more chemistry. You're going to need some pharmacy. You're going to need some controlled release. You're going to need a lot of big data analysis, because there's a lot of data out there on the duds that isn't being used. Okay? Could you build a curriculum around that? Yeah, I think you could. Are we making any effort in that direction? No. But that's all right. Maybe we need to think about that. Maybe we need to think how we need to set things up for those students whom we're training, who will go for 40 years. So what have I told you? Grammar versus poetry. Remember that. Think about that. When your discipline changes, try to re-identify your grammar and your poetry. How is the core content taught? It's going to be lectures. And what you want to do, there's some things that are perfectly well done with Calvin. Okay? I think, for example, spelling. I've always thought I had great affection for President Jackson, who said that anyone who spelled the same word in the same way was not creative. And finally, what should the future content be? We got to have core. We don't want to abandon the whole core. We've also got to start thinking about where our dreams are, what we want to do next. Thank you.